We're going to be covering Chapter 4.7 and 4.8. We will be discussing completing the square and discriminants. So one way we can solve a quadratic function is to complete the square. And I'm going to demonstrate this with our first problem A. So we can recognize that x squared minus 8x plus 16 is the same thing as x minus 4 squared. So to solve for x, we will take the quantity x minus 4 squared and take the square root of both sides. Now we simply have x minus 4 equals plus or minus 5. Solve for x and we get 4 plus or minus 5, which can either be 4 minus 5, so negative 1, or 4 plus 5, which is 9. Moving on to a more complex problem, we have x squared minus 12x plus 4. So we're going to move the 4 to the other side. Next, we're going to make space for our third value in this form. So if you think back to our ax squared plus bx plus c, this is our quadratic function form, and we want this form when completing the square. So what number that is half of negative 12, what is the square root of that number? So the half of 12, negative 12, squared, so half of negative 12 is negative 6, and squared is 36. So plus 36, and we need to add this to both sides. So now we have this complete part of our equation. And this is equivalent to, if you follow the same steps you did in the previous problem, this is equivalent to x minus 6 squared. So we simplify the other side and we get 32. And now we're just going to solve the same way we did the other problem. Except this time we have 4 root 2 as our simplified version of root 32. Therefore we can have 6 minus 4 root 2 or 6 plus 4 root 2. Moving on to C, we have a constant in front of our quadratic equation, our quadratic function. So we have 2x squared plus 8x plus 14. And we're going to first divide everything by 2. So we have x squared plus 4x plus 7 equals 0. Then we're going to move the 7 to the other side again, leaving room here for our third value. Next, half of 4 squared, so 2 squared equals 4. We're going to add 4 to both sides. So this whole value here is the same thing as x plus 2 squared. Negative 7 plus 4 is negative 3. Then we're going to square both sides. So we have x plus 2, don't need the parentheses really, and then we have the square root of negative 3, plus or minus square root of negative 3, x equals negative 2 plus or minus the square root of negative 3. If you remember from last video, we can solve this as I root 3. And then we have negative 2 plus I root 3, or negative 2 minus I root 3. Next, we're going to apply this by writing a quadratic equation in vertex form. So we're going to move from this form to vertex form, which you may remember, or it's good to remember, that this is y equals a times x minus h squared plus k. So we need to have y plus something equals x squared minus 10x plus 25 plus 22. Now we got here by doing the same thing to this problem as we did before. So we have x squared minus 10x plus something equals 22, negative 22. And then we're going to have, this is 25 plus 25. So we have x minus 5 squared equals 3. And then we have x minus 5 squared equals minus 3 to get everything on one side. And this is our answer. And the vertex of this would be 5, negative 3, because that's hk, h and k. So section 8 of chapter 4 is titled Use Quadratic Formula and Discriminants. So just as a reminder, our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, and this is all over 2a. The discriminant is this part of the quadratic formula. Now we're going to solve a problem with imaginary solutions using the quadratic formula. So now we're at the point of our quadratic formula when we have the square root of a negative. And now we're going to apply complex numbers. So we have negative 4 plus or minus 2i over negative 2, which simplifies to 2 plus or minus I, which can be 2 plus I or 2 minus I. So once again, this is our discriminant, and we use it to determine the number of solutions and the number of x-intercepts in a function. So how are we going to use this? We're going to use b squared minus 4ac, which is this part of our formula, and we're going to plug in their values from this problem. So let's plug that in. We have b squared, so negative 8 squared, minus 4 times 1 times c, which is 17. 64 minus, not 28, excuse me. 64 minus 68. So we have negative 4. And is this number greater than or less than 0? This number is less than. So therefore, since negative 4 is less than 0, we have two imaginary solutions. This means that there are no x-intercepts. So if we have our graph here, it would look something like this. If we graph this, if we have a negative number. Now if we have 0 as our discriminant, we're going to have a solution that is like this. And if we have a number greater than 0 as our discriminant, we're going to have at least two solutions. So it could be something like this. So one solution, two solutions, and 0.